Okay, in this video, I'm just going to go over a couple of problems on interpreting the derivative. So I'm just going to go in the book and do numbers 3 and 4 in section 2.4. So 2.4 is just about how to interpret the derivative. And just the main thing to realize is that the derivative is the rate of change of the original function. So you need to think about what is the original function measuring, and then if that is changing, what is that measuring? So let's do 3. So it says the temperature T in degrees Fahrenheit of a cold yam placed in a hot oven is given by this equation f of t, this function f of t. And t is the time, so little t is the time in minutes, and capital T is the time in is the temperature in Fahrenheit. And so little f, the function f, is measuring the temperature of the yam. So the derivative is measuring the change in the temperature of this thing that you're putting in the oven, right? So when you put something in the oven, you're heating it up. And so how is the temperature changing if you're heating it up? Well, the temperature is increasing, right? That's what heating it up means. And so this means that for part A, the sign of the derivative is going to be positive. The change in the temperature is going to be positive. The temperature is going to be increasing. So the sign will be positive. And okay, so and then what are the units of f prime of 20? So f prime of anything, the derivative is measuring the change in temperature over time, right? So the units are going to be degrees Fahrenheit over minutes, right? So the capital T is measured in Fahrenheit, little t is measured in minutes. And so the units are going to be degrees Fahrenheit over minutes. And so the practical meaning of this statement that f prime of 20 equals 2 is that 20 minutes after you put this thing in the oven, the temperature is going to be increasing at a rate of 2 degrees per minute at that time. Okay, so that's number 3. So let's go to 4. Actually, let's do 5. So I'm going to do 3 and 5 because 4 is another temperature one. So let's do 5. So the cost C in dollars to produce Q quarts of ice cream is given by F of Q. So the input is quarts of ice cream. The output is cost, total cost, right, to produce these quarts of ice cream. So we want to say, what are the units of these numbers and what does the statement tell us? So, okay, so the first one is about the original function, right? So it says F of 200 equals 600. So the input is 200 quarts. The output is $600. And so this tells us that it costs $600 to produce 200 quarts of ice cream. And the units, the 600 is dollars, right? That's the output, is dollars. For the second one, the output is going to be dollars per quart, right? It's how fast does the Y value change when the X value changes. So it's going to be, the units are going to be in dollars per quart. And what is this telling us? F prime of 200 equals 2. So it tells us that when I'm producing 200 quarts of ice cream, the change in dollars per quart at that time is $2 per quart. So how you can interpret that is like, to produce the 201st quart of ice cream, it's going to cost me $2 additional dollars, right? The Y value of the original function is how many total dollars it costs to produce all of this ice cream. And so the rate of change is sort of how much is it going to cost to produce the next quart of ice cream. So you can interpret this as the 201st quart of ice cream, or you can think of it as the 200th quart of ice cream is going to cost $2 to produce. So these are just 2 examples of how to interpret the derivative. The main thing is you should think about what is the original function measuring, and if that's changing, what does that mean?